What happened?
The sound, it was deafening, absolutely deafening. And I mean, I just remembered this bright ball of fire that just went right over my head.
The plane hit directly below his office, but the floor held. He's here in part because his floor was reinforced and held up for half an hour. In an astonishing stroke of luck, the terrorists had hit the only section of the Pentagon, the only section designed to resist a terrorist attack. Lee Evey runs a billion-dollar project to renovate the Pentagon. They've been working on it since 1993. The first section was 5 days away from being finished when the terrorists hit it with the 757. To see how so many escaped, you have to look inside the walls. The renovation project built strength into the 60-year-old limestone exterior with a web of steel beams and columns.
So you have these steel tubes. Again, they start on the first floor, go all the way up to the 5th floor, and all the way through, from floor to floor, we have everything bolted together with horizontal steel as well as the vertical steel. So it's all put together in one strong matrix of steel. Supports, in cases, the windows, and provides tremendous additional strength to the wall.
When the plane hit at 350 miles an hour, the limestone outside shattered. But inside, those shards of stone were caught by a shield of cloth that lines the entire section of the building.
This is a ballistic type cloth. It helps prevent that masonry from perhaps fragmenting and blowing through an area where there are people.
It's essentially a bullet-resistant vest for the building.
That's, in fact, what they make bullet-resistant vests out of, is the same type of material.
All of this, especially the steel, held up the 3rd, 4th, and 5th floors. They stayed for 35 minutes. You can see them through the smoke, suspended over the hole gouged by the jet. Only after the evacuation did the heat melt the new steel away. The engineers studied past attacks, including the 1983 Marine barracks bombing in Lebanon, Oklahoma City in 1995, the U.S. embassies in East Africa, and the Khobar Towers barracks in Saudi Arabia.
At Oklahoma City, the bulk of the casualties were caused by the collapsing structure. So one of the things we studied was how to put redundant capability in a structure to prevent it from collapsing if it was attacked.
But there is an easier way. The Corps of Engineers is making a science of terror, setting off its own bombs. This is the first time the public has been allowed to see the Corps' counterterrorism work at its research center in Mississippi. Once the area is all clear, they set off a bomb. Inside, the destruction is captured in slow motion. They've done hundreds of these tests to create new kinds of building materials. For example, watch what happens to this concrete wall. Now look at the same kind of wall after it's been sprayed with a new plastic coating.
It's not just a pretty movie, it's an actual calculation.
In a special 3D imaging room, Mosher showed us how the supercomputer recreates the blast wave at Khobar Towers and predicts the path of every shard of glass from a single breaking window.
Just reach up and pick them out.
These studies have helped create a new generation of window that can stand up to tremendous force. This experiment shows how those new windows can be fitted into an old building.
So the window is strapped in. So what you have here is glass on the outside, glass on the inside, with this plastic sheet in the middle.
Right. It retains all the glass particles when it's hit. They all crack, and it's actually connected into the frame so that it gives it strength to keep it from blowing in.
But neither the heat nor the force broke through the windows that were right next to the impact site. The Pentagon's new windows cost $10,000 apiece. No one has counted how many lives they saved.